This is a similar but different question from Pure 1, exercise F, and it's based on question 8 from that exercise. So we're given 3 points, but one of the points we're only told the x coordinate, not the y coordinate, and we're told that the angle at E is 90 degrees and that B, the unknown, is more than 0. So we need to first of all show that B must be 9, and then we find an equation for C. So the first thing to do is just write down what we know. As soon as we see that DEF is a right angled triangle, we know then that we can use Pythagoras, and that seems to be the obvious way to solve this question. So we state what being a right angled triangle will mean, substitute in the values that we have, and form an equation. We multiply out the brackets, collect the terms, and solve to find the 9. Notice that there are 2 solutions, but this one would be -1, and we know that B is greater than 0. For part B, we do the same. We first of all state what we know. Because we know that the points D, E, and F are all on the perimeter of the circle, and we know that the angle DEF is 90 degrees, that tells us that DF must be a diameter of the circle, remembering that the angle in a semicircle is always 90 degrees. So we know then that the center of the circle is the midpoint of DF, and the radius is just half of the length DF, and we've already calculated the length of DF, root of 100, so we want half of that, which is just 5. So we can just write down the equation for C. I'm going to use GeoGebra just to have a look at how it's coming out. So I've typed in the 3 points, just like that, and I'm adding line segments to join them together. Just got to do one more between E and F. So that's there, segment, and then I literally just click, click. So first thing I'm going to check, is it really 90 degrees? Have I done that correctly? So I'm going to use the angle tool, click on that line, click on that line, and yes, it is 90 degrees, so I've got that bit right. I will draw the circle, though the truth is you can always do a circle through any 3 points, but still, nice to see I've done it right. Good.